Hello students, this is Miss Hagen. Today I'll just be going over the handout Mountains into Molehills. Sort of our objectives for this handout. Okay, we want to be able to convert from mass into moles, and then we want to be able to do the opposite, from moles into mass. So sort of the frame for the first part that we're going to go over, okay, is cyanide, CN minus. So CN minus is toxic. I believe that it's found in peach pits, and it has a lovely, lovely peach smell. So if anyone has ever told you not to eat peach pits, it's because of the cyanide. So down here in this table, okay, there are 4 different cyanide compounds listed. So sodium cyanide, potassium gold cyanide, and magnesium cyanide. And there are a couple different things you need to do for each of these compounds. 1, you need to find the molar mass. 2, you need to find the number of moles of the compound in 2.5 grams. And third, you want to find the number of moles of CN minus, not the whole thing, only the CN minus in 2.5 grams. Okay. So the first step to do this is to find the molar mass. So for the example that's given for sodium cyanide, they came up with the number 49.0. They got this by looking at the periodic table. So they went and looked at the mass for sodium, Na. Okay, they looked at that mass. Then they looked at the mass for carbon, and they added that. And then they looked at the mass for nitrogen, and they added that. So I believe this number is 22.99, 12.01, 14.01. Add those all up, you should get 49. Okay? So if you do that for the rest of them, these are the numbers that you get. Okay. These last two are a little bit tricky. I'll just show you for the last one how we got this 76. So we looked at magnesium, Mg. Okay, and there's 1 magnesium. That 2 outside the parentheses means I have 2 of everything that's in here. Okay, so I have 2 carbons and 2 nitrogens. So if you were to look on your periodic table and add those up, you should come up with 76.35. So the next thing that you were asked to do is to find the number of moles in 2.5 grams. Okay, so I'm looking right here. And I'll just give you a brief example for how they did this for sodium cyanide. So we always start with the things that's given. I'm going to work up here. So 2.5 grams and put it over 1. Now our key to change from grams, 2.5 grams, into moles is our molar mass. That's going to be our key. Okay. So I need grams on the bottom so that grams cancel out. I'm going to use the number for sodium cyanide. And molar mass means the number of mass, the number of grams in 1 mole. So 1 mole can go on the top. Grams will cancel out, okay? And you're left with 2.5 or 49.0 moles. And I'll leave you to do that on your calculator. If you do it out, you should come out with 0.51. So they repeated that for the next 2, okay, for here and here. And then I'm actually going to leave the last one blank, and you can do that on your own. So it'll be the same setup for example, for this one, 2.5 grams, but you're going to change this number right down here on the bottom. Okay? Instead of using 49, you'll use the 65. So you can figure out how we got these numbers. The last column is a little bit tricky. Okay, so if you look with me at sodium cyanide, there is 1 CN in sodium cyanide. 1 CN in the whole thing. Therefore, the number of the moles of the whole thing will be the same as the number of moles of CN, because it's 1 to 1. Same for KCN. For this potassium gold cyanide, though, it gets a little tricky. For every 1 potassium gold cyanide I have 2 CNs, 2 cyanides. Okay, so you have twice as many cyanide pieces as you have of the whole thing. So if you multiply this by 2, you should come up with this answer. And I'll leave you to figure out the last case, magnesium cyanide. Is it more like the first 2 cases or like the third case? Okay. I'm going to move on to the questions. So the second question asks you to explain how you determine the number of moles of CN minus. It's basically asking you, how did you come up with this last column here? Okay. Number 3, based on the number of moles of cyanide, place the 4 compounds in order from most toxic to least toxic. Okay. So once again, you're looking here. Most toxic, will that have the most cyanide or the least cyanide? The most toxic, most cyanide or least cyanide? think about that, figure it out, and then you're going to start with the one that's most toxic, and then the next most toxic, and then least toxic. So we'll be listing all 4. Okay. Number 4 asked you about potassium gold cyanide, okay, and why there's so few moles of cyanide. So if you look up here, this number is quite a bit smaller than the other 2. Why is that? Why is this number smaller for potassium gold cyanide? And the last one, which has more moles of cyanide, that's the CN, 1 gram of NaCN or 1 gram of KCN. So there's a couple ways you can approach this. You can approach this with math, kind of like we did up here, but instead of 2.5 grams, now you're talking about 1 gram. That's one way to approach this, to do the math out and then compare the number you get. Another way is just to think about it, to think about the molar masses. So I'll let you do that one on your own. Okay, the second page, all right, it asks you to convert moles into mass and mass into moles for some common vitamins. So we're talking about retinol, we're talking about vitamin B6, and we're talking about vitamin C. So one thing you've noticed is that I filled in the molar masses here. They're blank, and you should do the same. So I got these numbers by looking on the periodic table. I have 8 carbons, 11 hydrogens, 1 nitrogen, 3 oxygens. Okay, that's the number you should get. Another important thing, don't miss this, 1 gram equals 1,000 milligrams. So I'm looking here where it gives me milligrams, and I need to convert in grams, and I'll give you a little example. So I take 1,000 milligrams, put it over 1. Okay, I need to cancel the milligrams, so they need to go on the bottom. Grams can go on the top. And when I look up here, I find it's 1,000 milligrams for 1 gram. So that's how I got these numbers here. It also asks you to convert from grams into moles. So I'll give you a brief example for right here for how I do that. So I'd start with the grams, 1.0 grams, put it over 1. And here's where I have to use the molar mass. Okay, so grams has to go on the bottom, moles on the top. I want to get 2 moles. In 1 mole, I have 286.5 grams. If you were to do this math, you should come up with the number that goes in this box. So that's what you should do here, 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 and here. And down here. These where it gives you moles is a little bit different. Okay, it's a little bit tricky. So I'll do one for an example. So I start with what I was given. Notice this time that my units are moles. Over here the units were grams, here it's moles. Okay, that's because it came from this column. Alright, now instead of grams on the bottom, I want moles on the bottom, and I want grams on the top. So if I look up here, okay, it's 169.2 grams in 1 mole. You do that, you should get the answer that goes in this box. Then think, how can I take grams to milligrams? It's like this, but it's a little different. Okay, watch those units. Okay, moving on to the questions. Number 2, which has more mass, a mole of vitamin A or vitamin C? Here's vitamin C, here's vitamin A. You want to think about what's the mass of 1 mole? I think you can answer that. Which has more moles of carbon atoms, 169.2 grams of vitamin C, vitamin B6, or 176 grams of vitamin C? Okay, I'm looking at vitamin B6. Notice 169.2, 169.2. Okay, those grams are the same. That means this is 1 mole of vitamin B6. Okay, because this is the mass of 1 mole. Okay, 176.1 for vitamin C. Oh, same. Okay, so here we're also talking about 1 mole. So if you have 1 mole of each, which has more carbon atoms? This is where you're going to have to look at the chemical formula to answer this question. Okay, which will have more carbon atoms. Number 4. Explain how to convert from mass in grams to number of moles when you know the mass and chemical formula. Alright, basically, how would you get from grams to moles like we did here? How do you do that? Number 4, how can you convert moles into grams? Okay, how do we do this up here? It's asking you to explain it in words. The last one is a bit tricky, so I'll work through it with you. Okay, so my strategy is going to be to go from milligrams to grams, and then from grams to moles, and I can do that with a molar mass, and from moles to number of molecules. So I'm going to start out with my milligrams, what's given in the question, and put it over 1. Then I know that I can convert from milligrams into grams because I have 1,000 milligrams in 1 gram. Milligrams cancel out. Now I'm in grams, and I know I can get from grams to moles. I'm going to have to look up here. Okay, 176.14 grams in 1 mole. 176.14 grams in 1 mole. Okay, and here's where the tricky part comes in. In 1 mole, I have 6.02 times 10 to the 23. In this case, I'm interested in molecules. So if you do this math out, you would come up with the right answer. All right, next page. So these were the notes we took in class, I think, on Monday, I think. Okay, so I'll just show them briefly. Pause the video at this point if you need a chance to copy them down. There's 1 and 2. Here's 3. They're just examples for you. Okay. Question 1, you're crossing out. I didn't give you enough information to answer it, so you can cross that out. Question 2 is a little bit interesting. So there are 8 moles of H atom and 2 moles of CH4O. How many moles of H are there and 2 moles of C2H6O? I'm not sure I said that right, but you know what I mean. So if I'm talking about 2 moles of CH4O, okay, I've drawn that here. How did they come up with 8 hydrogens? And then if I have 2 moles of C2H6O, how did they come up, or what number would you come up for the hydrogens? So I'll let you think about that. Okay. This next page lists these compounds in order of increasing moles of molecules. And it says 2 grams of a whole bunch of different stuff. I kind of help you out. I kind of get you started. Okay, that's what I'm trying to do here. So I start off with what was given in the problem, put it over 1, and then you'll have to fill in the molar mass. So in 1 mole of CH4O, there are 32.05 grams, and do that math out. Repeat for H2O and C8H18, and then you'll be able to rank them from smallest to largest. That's increasing. This next one is a little tricky. Which has more moles of oxygen atoms? Barium oxide or barium dioxide? Okay, so once again, I kind of help you out. I start with what's given in the problem. Okay, then you're going to need to convert to moles. So you're going to have to put in the molar mass. So I'm helping you out here. If you were to look at your periodic table and look up barium and oxygen atom together, you come up with 153. Okay, you can do this math out and find the number of moles. Do something similar for barium oxide. This last piece, though, is the tricky piece. In 1 mole of BaO2, barium dioxide, how many moles of O2 are there? If you said 2, you had the correct answer. So there are 2 moles of oxygen. So that should help you figure that out. Okay. This next one is pretty simple. You're given moles, asked to convert to grams. Okay, so you can go back and look at the examples we've done for cutting from moles to grams. And then I want you to put them in order from smallest to biggest. All right, and for the last page, this page is a little bit, it's probably the trickiest page of them all. Okay, so you're running a company and you buy copper and then recycle the copper and resell it. So you want to get the most copper for the least money. That makes sense. So there are different suppliers and they want to sell you 1 mole of CO and the other supplier wants to sell you 1 mole of CO3 and the last one wants to sell you 1 mole of Cu2O3. And they're all offering them for the same price. So the first one, which has the greatest mass, you know how to convert from mass to moles, show your work. For B, which has the greatest mass of Cu. Okay, so up here, if you have 1 mole of CuO, how many moles of Cu do you have? If you have 1 mole of CuCO3, how many moles of Cu? If you have 1 mole of Cu2O, how many moles of Cu? This last one's going to have a different answer from the rest. Okay, and then the last one, which is the best deal for your company? Basically, which one gets you the most copper? Okay, if they're offered for the same price, how do you get the most copper for your money? Question 7 is asking you to think. It's not asking you to use Anything besides your brain? You don't need your periodic table. So you have two containers. All right, you have a first container. I'll draw that here. And a second container. So I'll make this A and this B. So this one, down here at the bottom, there's some solid copper. There's 1 mole of copper. Okay, and then you also have, as a gas, 1 mole of O2. On this one, you only have the gas. It's a different gas. It's the CO2, and you have 1 mole of it. All right? So how will they compare in terms of number of atoms? So you think about number of carbon atoms plus number of oxygen atoms, here and here. How will they compare in terms of the number of gas molecules? It doesn't say gas atoms, it says gas molecules. And the last one, how will they compare in terms of mass? So I hope that this was helpful. If you still have questions, come see me in class.